All right, it's time for some challenge problems finally. So we have the square root of 64, x to the fourth, y to the 16th, z, and we're going to use the properties that we know to go ahead and simplify this. This focus will be on changing these problems so that they have fractional exponents. So first of all, you think about what's going to be most useful to you. 64, I'm not going to write that as 64 to the 1/4 because I know right away that the square root of 64 is equal to 8. The reason why I can think of it separately, apart from x to the 4th, y to the 16th, and z, is because we know we can write this as the square root of 64 times the square root of x to the 4th times the square root of y to the 16th times the square root of z. So I'm allowed to separate those. So I'm going to go ahead and write the square root of 64 out. It's either positive or negative 8. I'm just going to leave it as a positive 8. X to the 4th, I find it useful to write this as x to the 4th over the root of 2. The y to the 16th, I also, thinking about it, realize that it is going to be useful to write this with a denominator of 2. The z is just going to be written as 1/2, and that's not helpful to me, so I'm going to go ahead and leave that z underneath the radical because I know I'm just going to eventually go back to putting it underneath the radical. So now we have 8x squared y to the 8th multiplied by the square root of z. And that's going to be my final answer. All right, number 2. Once again, I can think of this as the square root of 49 times the square root of x to the 5th times the square root of y to the 20th times the square root of m to the 3rd. The square root of 49 I know is 7, so I'm just going to write that here, positive or negative 7. X to the 5th, when I think about it, is not really going to be helpful. I don't know why I keep writing 4. All right, so it should be a power of 5/2 because this is a 2 here. Because it's a square root, so there's a root of 2. I realize that that's not really going to be that helpful, but I'm going to show you 2 different methods for dealing with a number like 5 that is not a multiple of your root. So 5 is not a multiple of your root. We'll deal with that. Y to the 20th. Well, 20 is a multiple of 2, so that's really convenient. M to the 3rd, also not a multiple of 2, so that causes me a problem. This next stage, I'm going to just simplify. 7, leave this alone, y to the 10th, and then I'll also leave this alone. At this stage, here's one method you can use. All right, method 1. I can say, all right, well, I know that I could write this out as 2/2 times x to the power of 2/2 times x to the power of 3/2. I could write this as y to the 10th. I could write this as m to the power of 2/2 multiplied by m. Wow, just having issues. Sorry, m to the power of 1/2. Because if you think about it, when the bases are the same, you add them up. 2/2 plus 3/2 equals 5/2. 2/2 plus 1/2 is equal to 3/2, so I'm just breaking it apart. There's lots of different ways that I could have broken up this set right here. So I could have also broken up this set, I'm going to show it over here, as x to the power of 4/2 times x to the power of 1/2. Lots of different options. So if I did it this way, it takes a lot longer. I get x to the 1st, then I get x to the power of 3/2, then y to the 10th. Over here I get m to the 1st power and m to the 1/2 power. And then I have to break this up again. So I get x to the 2/2 times x to the 1/2 times x to the 1st times 7 times y to the 10th times m to the 1/2. And again, I get an x to the 1st. Well, an x to the 1st multiplied by an x to the 1st, bases are the same, you add them up. I want to contrast the 2 different processes I used. Over here, look at this. I realize that 2 over 2. 2 is a multiple of 2. It's the largest multiple that I can get out of 3. And then I have left over 1/2. Over here, I took out one multiple of 2, but technically I could have pulled out two multiples of 2. For example, like I have up here, I could have pulled out a 4. So I could have said right away that I had x squared and x to the 1/2. So this is what you want to be able to do right away, is have the largest multiple of 2. So you need to think it through. If you have 5 halves, well, below 5 is 4. And 4 is a multiple of 2, so we could have used 4 halves and 1/2. Something you just have to think about. So at the end here, what we're going to have is 7x squared. And then I'm going to write that beside y to the 10th. I'm reordering according to the commutative property of multiplication. The m next, and then both of these that need to go underneath the radical, I'm going to put back underneath the radical. And I can combine it using what I know about the properties, and my final answer is 7x squared y to the 10th m. And that's my final result. All right, we're going to continue to use this problem, and we're going to look at another method. So the other thing I could have done with this problem is I could have realized that right away I could have split up the radicals differently. So what I'm going to do this time is I'm going to split this up into the square root of 49 multiplied by the square root of x to the 4th times x times the square root of y to the 20th times the square root of m squared times m. What you should be noticing is that I'm making sure that I have a multiple of 2 by itself, and I should only have a small x, a small power on my x left, or a small power on my m left. And here it's only a power of 1. Can't pull out anything else from that. So now I get 7, and I'm going to write this as the square root of x to the 4th times the square root of x times the square root of y to the 20th, or I could write this as, I'm going to go ahead and write this as 20 divided by 2 multiplied by m squared, the square root of m squared multiplied by the square root of m. Okay, now from here, what times what equals x to the 4th? Well, x squared. Or you could go ahead and take x to the 4th and divide it by 2 since the root is 2. I'm going to leave the square root of x alone because I can't simplify that. I get y to the 10th. M times m equals m squared, and then I get the square root of m. So my result is 7x squared y to the 10th m times the square root of xm, or mx. So I get the same result, but it's just a different way of thinking of it. I'm hoping that you're becoming more familiar with how you can manipulate these expressions to get simpler forms. Let's move on to the next challenge problem. So we have the cubed root of 64x to the 9th, y to the 12th m. Well, I know that the cubed root of 64 is 4. I'm going to pull that out right away. Then I'm going to write x to the power of 9 divided by 3, y to the power of 12 divided by 3, because I know that 12 and 9 are both factors of 3, or multiples of 3, sorry. So then the m, I'm not going to write it as 1 over 3. That's a waste of time. I'm just going to leave it as the square root of m. So my final result is 4x to the 3rd, y to the 4th multiplied by the square root of m. And the final challenge problem. The cubed root of 27 is 3. And again, remember, I'm thinking of this as the cubed root of 27 times the cubed root of x to the 8th times the cubed root of y to the 27th. So I'm thinking of it as different pieces. I'm thinking of that in my head. Next, we have the cubed root of x to the 8th. And x to the 8th, well, the power 8 is not a multiple of 3. So let's back it up. 7, that's not a multiple of 3. 6, that is a multiple of 3. So what I'm going to do is I'm going to break this up into x to the 6th multiplied by x squared. Y to the 27th, well, 27 is a multiple of 3, so we have 27 divided by 3. I can just take care of that right away. Next, I'm going to take this x to the 6 and give it, I should have had 3's here all along. I'm going to give it the root of 3, and then I'm going to give 27 divided by 3. I'm just going to make that 9 now. And then in the next step, I can simplify 6 divided by 3 to 2. Leave the cube root of x squared, and then I have a y to the 9th on the end. And it's normal to write everything that's outside of the radical to the left side. So I'm going to write 3x squared multiplied by y to the 9th multiplied by the cube root of x squared. And this is my final answer. So there's different ways that you can represent this problem to get to this point, but hopefully this has helped you to better understand how to simplify with radicals. Next year, you're going to focus on this a lot more. The only thing that we were supposed to talk about this year is this idea of taking some number or variables and changing it so that it has a fractional exponent. That was the focus for this year, and you'll do a lot more with it next year in math too.